let us start this lecture just recapitulating what we have discussed in the last lecture. So, if you recall that we started with the thermodynamic problem being analyzed by two approaches. One is microscopic approach, other is macroscopic, right? And then we also looked at various concepts and definitions which are essential to understand the gamut of thermodynamics, because those are the language one has, or the word terminologies one has to be keep that in mind. And we looked at system and surrounding, and then system and surrounding together we call it as a universe. I also emphasize giving an example that to what you call it as a surrounding. If you remember that I took a example of a hot tea, and then I told teacup, and then I told like nearby wherever its properties will be changing due to the heat transfer from the hot tea to the surrounding, then only that region will consider as a surrounding, not very far away. And later on we move to the what you call the properties, right? If you remember that we looked at whenever system will be interacting with the surrounding, then it will be also the properties will be changing. Of course, before that we looked at various kinds of systems, right? System can be divided into three categories. Am I right? One is open system, closed system, and isolated system. The closed system is also known as the controlled mass system, where mass will not be changing during the interaction between the system and surrounding. However, there will be change of or interaction of energy interactions, right, between the system and surrounding. And question arises like how to choose that, when to choose. And open system where the mass will be also changing during the its interaction or the system interaction with the surrounding. I took an example of the geyser, what you use in your winter days for getting hot water bath. Am I right? So, I mean in that case the water will be entering into the geyser and some water will be going out depending upon whenever you are using, right? So, therefore, the mass is changing, and so also the heat interaction which will be taking place between system surrounding. Then I moved into what you call a concept, what you call property, and we talk about properties and then thermodynamic properties. If you look at thermodynamic properties are different than the other properties of the matter, right? And we told okay, like the pressure, temperature, volume, internal energy, enthalpy, entropy, these are all thermodynamic properties what we will be dealing with. And wherever there is a interaction between the system and surrounding, then one has to look at these properties and the change in properties, right? And what we call, how we will know whether it is a property or not. It may be a characteristic, it may be a variable, but it is not a property of the system. So, for that we told that it should be exact differential, right? There we stopped over. If you look at properties is very important, and let me just quote from Lord Kelvin, who was told that when you can measure what you are speaking about and express it in number, you know something about it, but when you cannot measure it, when you cannot express it in number, your knowledge is of a meager and unsatisfactory kind. It may be beginning of knowledge, but you have scarcely in your thoughts and advance to the stage of science. That means whenever you talk about science, the measurement comes into picture, and whenever your measurement comes into pictures, then you will have to measure the properties of a system, right? Isn't it? So, therefore, it is very important to identify the properties of the system and how it is changing during its interaction with the surrounding. So, if you look at what we did basically, we took a property as a function of x and y, then we looked at dP is equal to dou p by dou x when y is constant into dx plus dou p by dou y when x is constant into dy is equal to a dx plus b dy. If you look at what is that a is nothing but this term, right, this term. So, and then this condition has to be satisfied, dou a by dou y when x is constant equal to dou b by dou x is equal to y is constant. This is a mathematical form, but if you look at what is the meaning is that if you look at x is constant, if x is constant, that means what? That means this plane, if you look at, this is the plane, and if you take dou a by dou y, right, that means change in this, how it is happening, the slope is here, right, that is corresponding to this term. And when I say that y is constant, that means this plane, right, and dou b by dou y and dou b by dou x, basically it is changing with respect to x direction and this constant. So, both are in the same point. So, therefore, it is an exact property. So, this is the what you call physical interpretation I have shown you, so that you can have a feel. You might have used it, but you may not have that feel, right. This thing you might have used in your mathematics class, right, am I right? So, but however, one has to understand what is the meaning of it. So, let us take an example, like how we will use this condition to find out whether a variable is a property or not. So, let us say that differential for the volume, volume means this is basically volume per mole, right, specific volume we can call of a gas is given by following expression, dV is equal to R by P dt minus RT by P square and dP, where P is the pressure and T is the temperature, R is the gas constant, and we will have to find out whether this specific volume is a property or not, right. Of course, you might be knowing it is a property, but we need to know mathematically whether it is right or wrong. So, if you look at what we know, basically dV is equal to A dt minus B dP. What is A? A is nothing but your R by P, am I right? What is B? B is equal to minus RT by P square. So, what we need to do? We will have to basically look at whether it is a point function or not, and if it is a point function, then we call it as a property, otherwise no. That means for that to know whether it is a point function or not, we have to satisfy this condition, dou A by dou P when temperature remaining constant is equal to dou B by dou T when pressure remaining constant, right. That we will have to satisfy from this. So, what we will have to do? We know this A, we will have to differentiate with respect to P. What it will come? It will be minus R by P square when we differentiate this B term, right, and dou B by dou T P is equal to basically R by minus R by P square. So, therefore, this condition is satisfied, hence it is a property, right. So, by this one can really understand what is whether it is a property or not, ascertain whether a variable is a property or not. So, let us when we talk about these properties, thermodynamic properties particularly, then we will have to understand what kind of is it properties. It can be broadly classified into two categories. What are those? Can you people recall? One is intensive property, other is extensive property. So, what do you mean by the extensive property? That means, See, when you talk about property in a thermodynamic sense, it is basically property of the system, right. We are not distinguishing in there in the system itself. So, that extensive property will depend upon the extent of the system, right. That means it depends on the size of the system, am I right. So, example will be mass, volume, total energy and other things, right. I will take an example which you people might be knowing, right. You know that whether this milkman who supplies us the milk in our home, right, it will be supplying in your also hostel, is aware about this extensiveness of the property or extensive property. What it does? It takes maybe 1 liter of milk and mix with half a liter of water, then it becomes 1.5 liter of milky water, but he sells it as a milk to you people. Am I right? To us, all of us. Am I right or wrong? That means he knows that if I will divide this 1.5 liter into 1 liter and 1 liter after mixing, it will be the what you call remaining same, right, or it will be remaining same volume wise remaining same or not? It won't be. 1 liter is a half liter. So, therefore, that property is a extensive property. Let us take an example. Let us say there is a cylinder which contains oxygen 1 kg of mass and 1 meter cube, and it is at temperature 300 Kelvin and pressure of 100 kilopascal, right. And there is another cylinder B which contains same oxygen 1 kg, 1 meter cube and 300 Kelvin and 100 kilopascal. What is we allow it to interact with each other. Let us say there is a connected, it is connected each other, then it became a one system, right. If I call this is as a one system, right, volume, and there is another, I just join together or I connect through a tube with a valve kind of things, let us say. After that what happens? It became like what will be the volume then? Volume will be 2 times of that, because 1 meter cube and 1 meter cube 2 meter cube, and mass is 2 kg, 1 kg plus 1 kg 2 kg. Whereas what happens to temperature? Temperature is remaining same, and so also the pressure, right. And these properties which changes with the with addition of these 2 cylinder, and then it becomes extensive properties, and the properties which won't change even if you add this, then that is known as intensive properties, right. So, I will give an example, right. If I take some dal, dal price is very high nowadays, let us say Harar ka dal, right, Hindi little bit, okay. So, now I will mix, the one is good quality dal and other is bad quality dal together, right. What will happen? The quality will be changing, right. Then that quality itself will be which property? It will be extensive property. But if I take the same varieties of dal, right, and mix 1 kilo and 1 kilo together, it became 2 kilos, then what will happen? The quality is not changing because quality is same. So, therefore, the quality became the intensive property, whereas if you take the kg or the mass will be extensive property, right. That means how we will know that intensive property is basically independent of system size, whatever the size it may be, right, it will be independent. Generally the pressure, temperature, density, these are independent, these are the properties which are independent of the system size. So, therefore, we call it an intensive property, and there will be another property which call it specific property. Just now in the last example we looked at the specific volume per unit mole, and the volume per se is an extensive property, but the specific property which is specific volume for this example, like then it is an extensive, it is an intensive property. Okay. Specific property will be basically intensive property. So, I mean, if you look at, we will be using two terms. One is V, that is volume per unit mass, that is if you look at SI unit will be meter cube per kg, and there will be V cap. Some book you may find V bar people use, that is V by N, that is volume per unit mole, right. And some place you may find volume per meter cube per kilo mole kind of things that you can use. So, we will be using both intermittently in this course. So, let us look at pressure. So, what do you mean by pressure? In a gas or in a fluid, either a gas or a liquid, we call it pressure, basically force per unit area or force exerted by a fluid per unit area. Am I right? So, if you look at the basically pressure will be force per unit area, therefore, unit will be 1 what you call Newton per meter square, we call it as a Pascal. So, 1 Pascal is equal to Newton per meter square. And do you have a feel what is this 1 Pascal means? It is a very, very tiny number, tiny pressure, right. 1 Pascal is very tiny pressure. Why it is so? If you look at 1 atmospheric pressure is equal to what? 101,325 Pascals, right. That means 1 Pascal will be what? 1 Pascal will be 1 over divided by this, is a very, very small. And of course, some people call it as a bar. Bar, basically 1 bar is equal to 10 power to 5 Pascal, and 10 power to 5 is a big number, therefore, people use either it as a 0.1 megapascal or 100 kilopascal. And similarly, one can think of using basically 1 kg per centimeter square, this is in MKS unit, that is equal to 9.807 Newton per centimeter square. If you look at, this is basically 98.07 kilopascal. Am I right? Because 10 power 3 is kilo, so you can multiply 10 into this 9.8, 98 point, and this is equal to basically 0.9807 bar. If you look at this pressure also expressed in terms of PSI, pound per square inch, right. You might have noticed in some pressure gauge, right. You have seen the pressure gauge or somewhere, or in your anywhere have you seen? In some system also we are using mostly SI unit, but in some industrial application people do use the what you call FPS system, that is pressure per square inch. 1 atmospheric pressure will be equal to 14.7 psi, pressure pound per square inch, right. So, if you look at, that is generally in terms of the what you call in case of a fluid, that is a gas or a liquid, we talk about the pressure, right. In case of a solid, we call it as a what? Suppose I am applying a force on a solid per unit area, what do we call? We call it as a stress, right. Yes or no, right. And let us take an example, like there is a person who is was very up to mark kind of thing, his weight is something 68 kg, as per the height he was fine, comfortable, and then he is having what you call a feet area of 300 centimeter square, and the force what will be applying due to his weight on the earth or where he is standing is basically 0.23 kg per centimeter square, right. But now he has taken a lot of food and then become fat, his weight has increased double almost, let us say, which is not the case generally, and then it will be basically increasing the weight because his what you call foot area will be remaining same. So, you can think of using that this thing. So, that that pressure what being applied by the same person is become twice of that what it was earlier, because the mass has increased. So, gravitational force, if you look at is the same, that is the mg, right, and then therefore it is having. But here we call is normal stress, right, we call it as a normal stress because it is applied perpendicular to the area of a chubby person is much greater than 1 feet of a slim person. If it is a slim, earlier the person slim. Nowadays a lot of things are going on as to how to reduce the weight and kind of things, because our people becoming more fat day by day, right, what it was not. Obesity is increasing, like, and if you look at, I just want to draw your attention, maybe I will ask you a solution. So, what happened, one small boy is carrying a trunk which is having a very tiny handle, or a diameter of the handle is very small, but the weight is higher. He is getting pain in his hand. Am I right? Because of what? Because of pressure, right? And now you want to give a solution. What you will give? Any idea? Any idea? Like, you are an engineer, so you know the why it is happening. He is saying, I am getting pain, I need relief. I remember, like, when I was a kid going to the school, we are carrying a trunk, what you call a box, metal box, and in that we used to carry the books, not like your nowadays very fancy bags which you can hang on the back, right. So, like, if it is heavy, then you will get, and your hand will be getting pain, and it became a sometimes red color if you are carrying for a longer period of time. We used to walk maybe 2-3 kilometers to go to school, right. Okay. So, it will be like a red color kind of things. That means the pressure it is being subjected to high. So, what is the solution you are thinking of giving? Any solution? See, Indians are very good in jugaad, right? But I am not getting anything from you people. What is the immediate solution? See, what else? Suppose you are having handkerchief, okay? You use a handkerchief and make it, fold it many times, whatever possible, right? What you are doing by that? You are basically increasing the area. The force is same, area you have increased. So, therefore, what happens? The stress which will be developed on your finger or body, whatever it is, it will be reduced. You are relieved. Am I right? So simple. You should apply how it is. That is the very important thing. Similarly, an old man, he is trying to cut with a knife maybe a very difficult fruit or something to eat. So he is finding difficulties, and how he will solve his problems. So you think about it. We will discuss maybe some other time. So if you look at, these are the pressure gauge what I have shown here, right. Did you see any kind of pressure gauge? This is a basically pressure gauge. Where did you see? Cycle stand, right. So how does it work? What is did it make you to think, and then how it is functioning, how it is giving pressure, and what kind of pressure it is, right. So if it is not exciting, if you are not triggered by that, then you are not looking it scientifically, you are just looking like a layman. So we will be now, see, we will have to define also various kinds of pressure we will be handling, right. This is absolute pressure, that is basically the actual pressure at a given position, right. And it will be basically relative, it will be measured relative to the absolute zero pressure, that we call it as absolute pressure. There will be gauge pressure, right. Gauge pressure means the difference between the absolute pressure and the at local atmospheric pressure will be basically known as the gauge pressure, and most of the pressure measuring devices, right, what we use in our day to day life and engineering also, that will be measuring the gauge pressure, right. So, what the question I ask you, that whatever the gauge you must have used or you might have looked at it, particularly when you are giving the pressure or inflating your tire of the cycle or a car. I think some of you might be knowing how to drive the car and or motorbike, right. So, that pressure all the time the person will be giving or feeling your tire pressure, he will be checking whether it is proper pressure or not, am I right? With that there will be a gauge. So, that will be measuring the gauge pressure, and the pressure below the atmosphere is basically that vacuum pressure. So, if you look at, this is your absolute vacuum, or the P absolute is 0, and then if I say that pressure is here, this is the absolute pressure from here to there, and atmospheric pressure is this much. So, the gauge pressure will be basically absolute pressure minus the atmospheric pressure what we give the gauge pressure. But whereas the vacuum pressure will be atmospheric pressure minus the absolute pressure, it will give you the vacuum pressure, right. So, what we will be dealing in this class or in this course, that will be basically using the absolute pressure, although we will be measuring most of the time what you call the gauge pressure. Now, we are discussing about pressure. Let me ask you a question, like you must be feeling very often your or inflating your tire of your bicycle, am I right? Yes. And you might be also, maybe your parents will be having car, and they might be also what you call giving the pressure to their tire kind of thing. Which pressure will be higher, which pressure will be lower, and what will be the order of pressure? Can anybody, any guess? That car pressure in the tube of the car will be higher than the cycle pressure or the bicycle what we use in our campus, or it will be other way around. What is your guess? Car pressure will be higher. Actually it is not. Okay, you please think about it, why it is so, how it is so, and why it is, and I will tell you, you must not have looked at your tube or the tire on the wherever you are changing it. You must go and check what is the pressure given there, right. You will surprised to see, you must not have noticed. Any of you have noticed? You might have changed your tube or tire, no, right? Yes or no? Bicycle not changed, use and throw, am I right? But still then you will be changing, or you change the cycle. Nowadays that is the mode that you change, use and throw. But still then you will be changing, you just look at it. The pressure will be something around what you call maybe something 85 to 115 psi, it will be written. In India also we are having the colonial overhang, we are still using PSI. PSI is pounds per square inch. Okay. Now, suppose the rear wheel is there and the front wheel, right. So, where pressure should be higher? That is a simple question. Okay. So, you think about this thing. So, whenever we talk about it, we need to measure pressure. I told that there is a gauge which is being used. Let us look at that. This is a commonly used manometer. You might have solved a lot of problem on manometer before during your JEE exam, am I right? And it is basically commonly used to measure a small to moderate pressure difference. Like here we will be measuring the pressure difference. You can think of pressure difference as a gauge pressure, you can think of, or sometimes it will be. And most of the some of the manometric fluids are basically water, alcohol, oil kind of things, right. And we can also devise some these things which will be helpful depending on the situations. For example, question is where you will use mercury, where you will use water, where you will use alcohol, and that will be depend on the properties of these fluids, particularly the density. You know, like mercury is having what? Higher density than the water, and alcohol will be lower density. So also oil as compared to water, right. So if you consider 1 atmospheric pressure will be equal to how much of water head? Any idea? If you just calculate, it will be something around 10.3 meters of water head, right. So let us look at a tank which contains gas at a higher pressure, which is connected to a U tube manometer. This is just a simple glass tube with a graduation, so that you can measure the height, and this fluid, because of pressure it is pushed these things, this is a manometric fluid, right, and it has this level, and you can say that difference between this change in the manometric fluid height due to this pressure is h, right. So I want to find out, connect this h, because I can measure this height, right, and then connect and then calculate the pressure of the tank. So what I will have to do? What I will have to do? I can take, this is my reference, right, pressure. I can calculate what will be this height of that, and then I know the manometric fluid density, right. Let us say this is the density of the fluid, and then I know this is a gravitational force is acting, right. So I know that, and what is the pressure, what is it some pressure is acting here? What pressure it will be acting? What pressure will be acting here at this point? P atmosphere, right. So I can say that P atmosphere, right. So I will do a balance. What I will do, that P2 is equal to P atmospheric plus rho GH, this is pressure, plus rho GH, right. It will be changing with respect to height because of gravity. So then I can find out because I know this atmospheric pressure, I know the density of this rho is density of what? Density of manometric fluid, and G is your gravity, gravitational acceleration, right. And this gravitational acceleration will be changing with respect to height. Am I right? Of course, manometric in the same is this thing we are considering. So h is the height we can measure. Now, and then this P2 is same as that of the P. So therefore, we are saying the tank pressure will be same as that of the P1, right. So now let us look at the measuring the pressure drop across a flow section. In this device the flow is taking place, and we have connected with the station 1 with the manometers, right. This is U tube, and also there is a incline, sometimes people call it inclined manometer also, right. And I need to measure the pressure between this point 1 or the station 1 and station 2, right. So that is the thing we will have to, and if you look at, this is the height from here to this is your manometric fluid, and this height is the change in the manometric fluid, right. And this manometric fluid must be different than that of the flowing fluid. Let us say if it is water, then it can be mercury or alcohol or some other things, right. Of course, it will be difficult to have alcohol. So and if it is air, you can use here also water, right. And let us look at, we will have to calculate. See, if I look at this pressure P1 here, and then what will be at this point? At this point what it will be? Pressure P1 plus rho 1. Rho 1 is the density of the flowing fluid, G, and A plus H, this is the height A, plus H at this point. So, this pressure will be same as that of here at this point, and then what will say, you will have to go to this point, that is rho 2 G H, this term, right, and minus rho 1 G A. So, that is the nothing but your P 2. So, if you look at this rho 1 G A 1 can be cancel it out with this, right. So, therefore, P 1 minus P 2 will be nothing but rho 2 minus rho 1 G H, right. So, the change in density will be taken care, and the G H of course we know the height, and you can find out what will be the what you call change in pressure between the station 1 and 2. So, what I would like to say that you will be looking at this kind of the what you call pressure measurement, pressure, some kind of manometer and other things will be giving you some problem in your tutorial classes to solve you, and also you might have done this kind of things earlier, maybe you can recapitulate this. So, let us look at the other pressure measurements what one can think of. Of course, it is not very much related to thermodynamics, but I have given so that you can think about something engineering aspect of the gauge. What you might have seen in your cycle store or maybe car, wherever you are inflating your tube of the car, then you will be using a Bourdon kind of tube, which consists of a hollow metallic tube, which is closed at this end, right. Of course, there is a various varieties like C type, spiral type, twisted type, helical type, all are same. This comes under the Bourdon gauge or Bourdon tube. And what happens when the pressure is let us say it will increase here. So, what happened to the tube? The tube is having a cross section of a what you call rectangular cross section or elliptical cross section, you can say here. It is not a circular. When the pressure is higher, it will be changing, and it will be changing its position also, right. It will be inflated and trying to be more circular kind of things, and then this will move, and this point will be connected to your needle. There will be gear and pinion arrangement which you can open, you can see yourself. Then that will change, because there will be change in that. When at the initial condition it will be state, that means the pressure is 0, that means with respect to atmosphere, and all this atmospheric pressure will be acting here also, right. So, this will be giving you gauge pressure, and this whenever there is a deflection, it will be changed into that and it will give. So, this is a mechanical kind of pressure gauge, right, which will having certain inertia, but it can be used for a very high pressure. It can go to very high pressure. Of course, there are several to improve its sensitivity. There is a spiral type, twisted tube and helical type. There are several varieties kind of things that people have developed. And however, in maybe last 70 or 80 years, electronics has come into very big picture, and so that people can develop, change the convert this pressure effect into the electrical effect, right, such as the change in voltage, resistance and capacitance, because there is a change in this thing. You can use a diaphragm, and then there will be change in that deflection. You can convert into the voltage or the resistance or capacitance, then you can measure the pressure very easily. And this pressure, of course, this is known as transducer, pressure transducer kind of things, and are smaller and faster, right, and they are more sensitive, reliable and precise than their mechanical counterpart. But however, I feel that mechanical one is more reliable and rugged, whereas the electrical or the electronics kind of things, in our place where the humidity is very high and the temperature is very high, those are their life is very small, and then I always feel the mechanical will be more rugged in our conditions. Besides this, there is a strain gauge pressure transducer worked by having a diaphragm and is a deflect between two chamber open to pressure input. Let us say if it is gas pressure, atmospheric pressure and the input pressure. And there is another kind of things which is being used nowadays very much is the solid state pressure transducer, which works in the principle that whenever you press or you apply the pressure, then there will be a change in the crystalline substance, and then it will give you the electrical kind of things, energy and mechanical pressure, and that was known as piezoelectric transducer, right? That is being used, and it is quite it can take a higher amplitude of the pressure and also the larger frequency it can sustain. Therefore, in your IC engine, IC engine, piston cylinder engines, what you use in your car, there we want to measure pressure, we will have to use piezoelectric kind of transducers. So, what I would like to tell you is that, let us say this pressure also is very important. This thing, if you go to the higher altitude, if you go to the sea level kind of things, let us say you are having the what you call in the sea, if you want to get into down, what will happen to the pressure, what kind of pressure will be experiencing, right? Am I right? And if you look at the problem wise, it is quite complicated, because the density of the liquid of the water in a sea will be changing. Am I right? Because of what? Salt, right? Isn't it? So, salt will be there, the water density will be changing, there might be gradient and it might vary. And what happens to if you go to the very deep sea? Of course, it is very difficult for man to go to the very deep sea. With the modern technology one can go. Now, the G also will be changing, the gravitational, that wherever we are talking about pressure, G comes into picture. Am I right? So, the G is changing along the altitude, and so also the what? The sea depth or the inside the earth also it goes changing, right? But the G will be not really changing much, right? It will be changing something maybe 0.1 like kind of 1% of the G, average G, what we take 9.81 meter per second square. So, along with the height, it will be changing very less. Let us say for something for 1 like 1% will be changing maybe 100 meters kind of things, and therefore we will be taking the constant, right? But what will happen to the the gravitational acceleration at the core of the earth? Any idea? Just think about it, right? Whether it is changing or whether it will be because as you go down, the G increases from the sea level to the from the sea top level to the downwards towards the earth center. So, it will be increasing, but what happens at the center? As you go up, what happens? The G will be decreasing. Am I right? When you go to the higher altitude, G will be decreasing. Am I right or wrong? Okay. So, but the change is not much, we won't be considering here, and I will stop over here, then we will discuss in the next class about the energy and what are the forms of energy and other things. Thank you very much.